Lesson 15, May the 10th through the 14th, interpreting residuals from a line. Alright, we're going to look at this. Our goal, our outcome, hopefully after this lesson, is to use the least squares line to predict values for a given data set, and to use the residuals to evaluate the accuracy of predictions based on the least squares line. Alright, so let's go ahead and look at example number 1. Calculating prediction errors. It says the gestation time for an animal is the typical duration between conception and birth. The longevity of an animal is the typical lifespan for that animal. The gestation times in days and longevity in years for 13 types of animals are shown in the table below. Alright, so basically it's saying that for a baboon, the time from conception to birth is 187 days, and it lives for about 20 years. Alright, so that's what the data is saying. Alright, so then, here is the scatter plot for this data. Alright, so we have the scatter plot here. Make sure you look at this data pretty closely. Alright, so we're going to look into doing our regression line. Alright, well, let's kind of think about this for a second. Let's look at the scatter plot. Okay? How would I create my regression line? Well, we have learned how to enter the data into the calculator, and that would be the easiest thing to do, would be to use a scientific calculator and do a regression line. Now guys, you can use Desmos.com, and it will help you to, it's just like a scientific calculator. Alright? So don't be upset at the fact that you don't have one of the calculators here from school. You can get online and do Desmos.com, and that will allow you that scientific calculator. You can also download scientific calculators to your phone, to your computers, and there's a lot of them that are free and good. Alright, so let's go ahead and look at our best fit line. So what would we think? Okay, so if I were to create a regression line, I would think that it would look something like this, maybe. Kind of going through the middle of my data points. Alright? Because my data does, form that line. Alright? So I would think that my regression line would look something like this. Alright? Look at the vertical distance. Vertical distance here. I really want you to look at that. Of each point in reference to that line. Alright? One of the things that I want you to understand is that smaller distances, just like here, those smaller distances lead to more accurate predictions. Okay? Alright, so let's go ahead and look at exercises 1 through 4. Finding the equation of the least squares line relating longevity to gestation time for these types of animals provides the equation to predict longevity. How good is the line? In other words, if you were given the gestation time for another type of animal not included in the original list, how accurate would the least squares line be at predicting the longevity of that type of animal? Alright, so using a graphing calculator, verify that the equation of the least squares line is y is equal to 6.642 plus 0.03974x, where x represents the gestation time in days and y represents the longevity in years. Alright, so what we would do is we would go to our calculator and we would enter all of this information for that's on our chart. Alright, and I'm just going to go ahead and enter this really quickly. Hopefully I can do it quickly. I don't know. And I don't know if I may be able just to not enter it all. Alright, give me just a second. And we'll go back up and do the years. Alright. So I have my data entered. I'm going to go to data. Do a quick graph. Alright. And it told me that X was the gestation time. So I need to change that. And, whoops. Days. I'll make this years. Alright, so there's my data, and it looks similar to my scatter plot. This one on the calculator is quite bunched up because it only has half a screen. Alright, so now I'm going to do analyze. I'm going to do my regression line, and I want it in the form of mx plus b. And there we go, and let's look at the equation for it. And it looks to be the same exact equation that, yep, we get the same exact equation. Alright, so we have verified that that is the equation. Alright, now it says the least squares line has been added to the scatter plot. Alright, suppose a particular type of animal has a gestation time of 200 days. Approximately what value does the line predict for the longevity of that type of animal? Well, this is where we would plug in to our equation. So y is equal to 6.642 plus 0.03974 times 200. Alright, and we would get that equals 14.59, or approximately 14 6/10 years. Alright, would the value you predicted in exercise 2 necessarily be the exact value for the longevity of that type of animal? Well, we don't know. We don't expect the longevity to be 14.6 years, because let's go back and look. Animals that had 200 days, they lived 18, 20, 15, over 200 days, we don't expect that longevity to be 14.6 years. It might be longer, it might be shorter, we don't know. so we can't predict. We don't know for sure that that's the exact. All right, it may be longer, it may be shorter. You can investigate further by looking at the types of animals included at the original data set. Take the lion, for example. The gestation time is 100 days. You can also know that its longevity is 15 years. But what does the least squares line predict for the lion's longevity? Substituting x is equal to 100 days into the equation, you get y is equal to 6.642 plus 0.03974 times 100, or approximately 10 6/10. The least squares line predicts the line's longevity to be approximately 10 6/10 years. Well, the longevity is 15 according to our data. So it could be different. How close is this to being correct? All right. More precisely, how much do you have to add to 10 6/10 to get the lion's true longevity of 15? All right. So we predicted 10 6/10 for the longevity of the lion. All right. And it was actually 15 years. So what would I do here? I would do the actual minus the predicted. And when I subtract that, I get 4 4/10. And do you remember what this is called? This is what we did in one of the last lessons. This is my residual. All right. You can show the prediction error as 4 4/10 years on the graph like this. So they drew from the line to the dot and wrote the prediction error or the residual. All right. All right, let's continue to think about the gestation times and longevities of animals. Let's specifically investigate how accurate the least squares line prediction for longevity of the black bear. All right, so what is the gestation time for the black bear? Well, if you go back to your chart, it told us the gestation time was 219 days. All right, so it says, look at the graph. Roughly, what does the least square line predict the longevity of the black bear to be? Well, we're going to go to 219 days, which is right around here. So roughly about 15 years. All right. All right, so about 15 years. So use the gestation time from part A and the least squares line to predict the black bear's longevity. So let's do this. Y is equal to 6.642 plus 0.03974 times, it said 219 days. When I plug that into the calculator, I get round to the nearest 10th, 15 3/10 years. All right, what is the actual longevity of the black bear? It said 18 years. How much do you have to add to the predicted value to get the actual longevity of the black bear? Well, actual minus predicted would give us 2 7/10 years. Show your answer to part E on the graph as a vertical line segment. All right, so now you're going to go back over to your graph. We're going to find going to say, well, that it is 2.7. Okay? Alright. Number 6, we're going to repeat this activity for sheep. Alright, so substitute the sheep's gestation time for X into the equation to find the predicted value for the sheep's longevity. Round your answer. So Y is equal to 6.642 plus 0.03974 times the sheep's longevity is, alright, sheep is 154, or its gestation is 154. Alright, enter that into the calculator, and we get 12 and 8/10 years. Alright, what do you have to add to the predicted value in order to get the actual value of the sheep's longevity? It says, hint, your answer will be negative. Well, let's go and take the actual longevity of the sheep, which is 12, minus 12 and 8/10 gives me a negative 8/10 years. Alright? Alright, show your answer to part B on the graph as a vertical line segment. Write a sentence describing points in the graph in which the negative numbers would need to be added to the predicted value. Well, let's go back to our graph. And our sheep's gestation was 154. Alright, so this is where we're going to draw it. And that is a negative 0.8. Alright. And it says to write a sentence for which the negative number would need to be added to a predicted value. Well, why would we need to add a negative number? Because the point falls below the least squares line. So the residual is negative. Okay? If it would be above the not line, then it would be our residual, would be positive. Alright. So the concept of a residual. What do these residuals tell us? Well, it tells us how much needs to be added to the predicted longevity to get the actual longevity. Alright? Which type of animal has the largest positive residual? Well, let's just kind of look at this. The largest positive would be this. So that looks to be probably about the baboon. Alright, because it's the longest away. Alright. What type of animal has the biggest negative residual? So we're going to be looking at probably this animal here, which looks to be probably about the beaver. Alright. So I can look at this and see how much of an error I have. Alright, in this exercise, you found out how much needed to be added to the predicted value to find the true value of an animal's longevity. In order to find this, you have been calculating the actual value minus the predicted value. This quantity is referred to as the residual. It is summarized as the residual is equal to the actual y value minus the predicted y value. You can now work out the residuals for all the points of our animal's longevity example. The values of the residuals are shown in the table below. So they went ahead and figured them out for you. These residuals show that the actual longevity of an animal should be within 6 years of the longevity predicted by the least squares line. Suppose you selected a type of animal that is not included in the original data set, and the gestation time for this type of animal is 270 days. Substituting x is equal to 270 into the equation of the least squares line, you get 17 4/10 years. Think about the actual longevity of this type of animal. Think about what the actual longevity of this type of animal might be. Could it be 30 years? How about 5 years? Well, let's kind of go back and look. Alright? So we are looking at a longevity of a gestation time of 270 days. Well, we've got the black bear is 18 years. The bison was 15 years. The cow is 15 years. So, do you think it's going to be 30? Probably not. They won't live to be that long. Do you think they're going to live as little as 5 years? Probably not. Because these values are farther away from the predicted value than the errors given by the residuals on the table. Alright? It's unlikely that the animal will live as long as 30 years or as little as 5 years. Alright, because of the information on the table. Judging by the size of the residual on your table, what kind of values do you think would be reasonable for the longevity of this type of animal? Well, let's go back and look. Looking at my residuals, alright, I would probably say between 11 and 15 years, maybe even a little bit longer, because we do have chimpanzee live 20 years, so we should be, it says 6 years within that reach. So if I take the 17 and subtract 6, and the 17 and add 6, it should be somewhere between 11 and 23. Alright? Alright, continue to think about the gestation times and longevity of animals. The gestation time for the type of animal called the ocelot is known to be 85 days. The least square line predicts the longevity of the ocelot to be 10 years. Based on the residuals in example 3, would you be surprised to find that the longevity of the ocelot was 2 years? Alright? Why or why not? And what might be a sensible range of values for the actual longevity of the ocelot? Well, it's saying that the predicted would be 10 years. It's unlikely that the actual longevity would be 2 years, because then we would have a residual of 8. 10 minus 2 is 8. Remember, we said that our data says that we should be somewhere within 6 years. all right, which is, so 8 would be greater than the ones in the table. So it is unlikely that the longevity is 2 years, because that would be a residual of 8. Which is greater than our data. Alright? So it wants to know what might be a sensible range. Well, if I take 10 minus 6, that would be 4. Or 10 plus 6, that would be 16. So somewhere between 4 and 16 years. So between 4 and 16 years. We know that the actual longevity of the ocelot is 9 years. What is the residual for the ocelot? So actual is 9 minus 10 would give me -1. If the residual is close to 0, that means that my predicted value is closer to the actual value. If the residual is negative, it means that my predicted value is greater than my actual value. When a least squares line is used to calculate the predicted value, the prediction error can be measured by the residual is equal to the actual y value minus the predicted y value. Alright guys, that is the end of our lesson. Hope you have a great rest of your day.